Okay, so if you're waiting for me to answer it, if I write it up here, you need to write it on your paper. If all you do is write the answers, remember that's not worth anything at all. Alright, 220 people apply to work. After we review their applications, 1/8 could not work on Saturdays, 1/5 did not know how to work calculator. Approximately what percent of applicants could not work Saturdays or the calculator? So if it just says what percent, does it matter that 220 people applied? No. So this is just extra information. What we do care about is what? The percents that I can't do it. So we have 1/5 and we have 1/8. So what do we need to do with those two numbers? We need to add them together because you have one group of people and a second group of people, and you want to know how many people is that all together, so you're combining them. So we have 1/5 plus 1/8. So why do we change it to 40? Because we need a common denominator. So we have something over 40 plus something over 40. How many 40ths is 1/5? How do we get from 5 to 40? Times 8, which means we can do 1 times 8, which is 8. About 1/8, how can we get that to 40ths? Times 5. So that's going to be 5 40ths. So what's 8 40ths plus 5 40ths? No. It's 13. That's the reason why we find a common denominator, is because we don't add the denominators together. Okay? Two ways we can do it from here, because we want this as a percent. We could either turn this into a decimal by dividing and then moving the decimal point 2 places, or we can think if it's 13 out of 40, what is that out of 100%? So we can cross multiply and divide. So 13 times 100 is 1300 divided by 40. We can drop 1 0. 4 goes into 13 3 times. 4 goes into 10 2 times. And we get 32.5%. Okay? There's a third way you could do this that's a lot easier if you know your fractions. If we know 1/5 is 0.20, right? Hopefully we know that. If we know 1/8 is 0.125, and if we add those together, we get our answer. So we could have converted them before we did any math and then added those up. Okay, so just different ways to get the same answer. As long as you get the answer, that's good. All right, number 2. Two parallelograms are similar. A smaller one has base 2.8, height of 3.5. Larger one has base 4.2. What is the larger one's height? So what's going on here? Proportions. Why is it proportions? Because it says they're similar and it says we're comparing, and it doesn't talk about scale factor and changing the area, so we can assume this is just going to be an easy proportion problem. So we can draw our two parallelograms, and we can be lazy about it. Here's my parallelogram. Is that a parallelogram? Yes. What kind of parallelogram is that? That's a rectangle. Remember, a rectangle is just a parallelogram with right angles. So we have our large one, has a base of 4.2. So what would that need to correspond to on our smaller one? 2.8, because it says base, so it's got to go with base. And we want to know the height, so we call that x. Okay? So we can compare, we can say base to height. Change this up a little bit. So what's the base of one shape? 2.8. 2.8. What's the height of that same shape?
3.5.
And over here, the base is
4.2.
over x. No. Wait, yes, you'd get the same answer. That would be comparing little to big. As long as when you cross multiply you get this step first, you're okay. So hopefully we're working this out, not just sitting there. I thought you were going to do all the work for us. I just want to be lazy. I'm not here to do math. I'm here to show off my swag. Look at my new shoes I got. And I say they're new, but they're only new to me. I actually bought them from a guy who bought them from some other guy, but he only wore them one time. I'm going to assume he didn't have like athlete's foot when he sold that other guy the shoes that guy then sold to me. Couldn't possibly be anything wrong with that. No.
Oh, you're not? What you talking about? You thought so too? Okay. Yeah, she's right. Yes, I was right.
So we multiply, we get something like that, yes?
Yeah.
How many decimal places?
2.
2. What do we do with that?
Divide.
Divide it by 2.8.
2.8. Yeah. Remove the decimal.
Since we don't want to divide by decimals, we move it over. So we say, how many times can 28 go into 147?
I'm going for 4.
4.
5. 4. 5. 7.
Hopefully we wrote this down. So let's see, what is 28 times 4 and 28 times 5?
28 times 4 is 5.
So this is 2.
It's 6.
Wait, that doesn't seem right. Because it's not. Yeah.
It's 104. Yeah, it's 104. 112.
And then this next one would be 140. So our better answer would be 5. We subtract, we get 7 left over. Add a decimal, and a 0. 28 will go into 70, about 2 times. And since everything else is to 1 decimal place, can we leave that as 1 decimal place? Yes. So we can say our answer is 5.2 centimeters. Since it's just a side length, that's only in 1 dimension, so it's just centimeters. Okay, make sure you got all this down. Hopefully we're not trying to squeeze all that onto the paper.
I'm good at writing time.
Alright, number 3. Right triangle of sides is 6, 8, and 10. So we can draw ourselves a right triangle here. Okay. There's a second larger triangle, and the ratio is 1 to 5, which means what's our scale factor going to be? How do we get from 1 to 5?
Times 5.
Times 5. So our scale factor is?
SF equal F. I'm just saying stuff.
I know.
But is it not like a 3, 4, 5?
Yes. So we take all of our original sides, like this one down here would be 8 times 5, which is 40. This over here would be 6 times 5, which is not 6.5. 6 times 5 is 30. And the side we really care about, 10 times 5 is 50. And since all it wants to know is the hypotenuse, which is the side opposite the right angle, the long side, C. So this is 50 centimeters. Then we just need to make sure we read the question very carefully. It says how many meters is that?
5 meters.
So if 1 meter is 100 centimeters, what part of a meter is 50? Would be half of a meter, or 0.5.
So can we write 0
Okay. Just make sure you read the question carefully. Okay. Alright, number 4. A piece of steel is shaped like a right triangular prism. So again, we can start by drawing our shape. So we have a right triangle and another right triangle. And we connect our corners. So there's our piece of steel. Super. Alright, the steel has a volume of 220, so we can say V equals 220. Each base has an area of 10. So what can we call that? What do we use to represent area of the base? Big B, thank you. So the area of the base is 10. And then it says find the altitude. What do we think it means when it says altitude? If you think of like a plane, altitude is how high it is in the air. So altitude just means height. So that's what we want to know. So then we just look. No. No. We would just use a squared plus b squared if it said what is the length of one of the sides on the right triangle. Okay? So since we're looking at volume, do we have a formula for volume of prisms? You say yes, it's volume equals big B times the height. Okay? And then we fill in everything that we know. What do we know? We know the area of the base is 10. What else do we know? We know volume is 220.
So would we work backwards and divide it?
Yes. So we have 10 times some number equals 220.
The height's 22.
So how can we get our height? We can, instead of multiplying, we work backwards. We say, what is 220 divided by 10? And we just get, so the height is 22 inches. Okay. 4 down, 16 to go. All right, at the same time of day, a person who is 5 feet 2 inches tall casts a 3 foot 4 inch long shadow. So we need a guy or a lady. Right? And our person has a shadow. And then we have a building. It's got a door, a couple windows. It's got some words hanging out the side. Okay. And it has its own shadow. So really, what are we doing here? It's a proportion. These are going to end up being two similar shapes. So we're comparing the shadows to what? Okay, this could be the person's shadow compared to... No. You're forgetting the other part here. Shadow and what? What else?
The person.
What about the person? The height. Thank you. Somebody see me fill in our numbers. Well, an easy one is the shadow of the building because that's just 12 feet. The building height is what we want to know, so we call that X. And then we have this jerk of a person who's not even. If he's 5 feet 2 inches, how can we write that as... Yeah. How can we write that as just feet and don't say 5.2?
Take out 5 feet.
This is 2 inches out of what?
Oh, I see.
Okay. Out of 12. Because 2 inches is 2 parts out of 12. So it's 5 and 2/12. Whoops, there's no times there. And his shadow is 3 feet 4 inches. So that would be 3 and 4 out of 12. Okay? Because 4 inches out of 12, which would make a whole foot. So what we need to do is, since we probably don't want to solve proportions with mixed numbers, can we turn 2/12 into a decimal? Yes. Could we simplify it first? So this is going to be 1/6. What's 1/6 as a decimal? Please don't guess. Work it out.
Oh, 0.1.
Sure.
You get 0.16.
So we get 0.16, so the height of the person is going to be 5.16. How about the shadow? 4/12 simplifies to 1/3. So what's 1/3 as a decimal? Hopefully we know that one.
0.33.
That's 0.33. So it's going to be 3.33. Okay? So that's the person. We put the building on the other side. Where would the 12 go? With the shadow, so on top. And then X on the bottom. And let's actually make this a little bit easier. Since it's saying what is the building's height to the nearest foot, let's just drop the decimals. I'm going to assume you guys can multiply and divide decimals. So 12 times 5 divided by... So the height of the building should be about 20 feet. Which means our actual answer, since we rounded both of these down, would probably be closer to what?
21.
Like 21 maybe. We actually worked it out. we could say 12 times 5.16 divided by 3.33. I should round down. And that makes sense since we're dividing by a number that we rounded down. So the answer actually gets a little bit smaller. But still, it's close to 20 feet. If this was a multiple choice test and your answers were kind of spread out, this would usually work. Now, if the answer said 18 feet, 19 feet, 20 feet, 21 feet, you would want to leave it as close as you can. But if the answers were like 10 feet, 20 feet, 30 feet, 40 feet, we could go with this.
Why is your calculator all different?
Better?
No,
Great. All right, number 6, 1880. Some guy created candy corn because he hated children. Today, 9 billion kernels are sold every year. That's gross. How many are sold in 1/4 of a year? Express your answer in scientific notation. So how can we find the quarter of anything? We divide it by 4. So if 1 year is 9 billion, what is 9 billion divided by 4? This is 2 point what? 2. It's not 2 repeating because we keep getting different results. This is 5. So each quarter they sell 2.25 what? Billion with a B. Okay? So then we just need to figure out how to write that in scientific notation. So we need to actually write it out as a number. So 225, if we just started adding zeros, so let's say, would that work?
No.
What would that be?
2,250,000.
All right, so this would be 2.25 million. So we need to add what? We need to add another set of zeros here. So now we have our 2.25 billion. Okay? Yes. Because we're actually writing out the number 2.25 billion. Okay? It doesn't matter at this point. Then come by after school. Okay? All right, to get scientific notation, remember we need to move the decimal. That'll create a number between what and what? 1 and 10. Where's the only place the decimal can go that'll do that? Between the 2 and the other 2. Okay? So part of our answer is going to be 2.25 times 10. Why is it the 9th power? It's how many times you moved it. The only mistake you could probably make with this is people who say 7, because they say there's 7 zeros here, it's got to be the 7th power. No. You have to count every place you move the decimal. So we can use the commas to help us. Each comma separates 3 spaces. We can say 3, 6, 9. So 2.25 times 10 to the 9th. That's about it. All right.
I'm guessing that you don't like
I don't see how anyone does.
we get extra credit?
Okay. Okay. All right, number 7. No. Cube has sides of the following numbers: 3, 5, 9, 5, 7, 3. What is the probability of getting a composite number? So first thing we need to remember is what is a composite number? It's not an odd number. It's the opposite of a prime number. So, if we made a list of our prime numbers, technically, 1's not considered prime. Depending on who you talk to. So 5, 7, 11. And we can keep going, but we don't need it. 6. There's no even prime numbers. Don't try that. So which of these are prime? 3 is, 5 is, 5, 7, and 3. Which means how many are composite? Just 1. So what is the probability of getting that? It's 1 out of 6. And that's it. That's all there is to it. Okay? No. Because there's still 6 different outcomes. Right. So the probability of getting a 5 would have been 2 out of 6. All right? Then it'd be it's a cube. There's always 6 sides on a cube. It's difficult to change that without making it not a cube. Or maybe we were. I don't know. I need to turn the volume up, otherwise I can't hear myself. Now I can hear me. No. Alright, number 8. I guess we should do this one. Create a stem and leaf chart which matches the set. So remember, stem and leaf. How did we separate our numbers to make a stem and leaf plot?
The one was for the 10, and the other one for the 8.
Okay. For a stem and leaf plot, the very last digit is the leaf. The very last digit is the leaf. Everything else gets to be the stem. So in this case, it's only the tens place, so what would our stems be? We start with the smallest one, which is 3. We look, what's our biggest number? 50. So our last stem would be 5, and then we put everything in between. It's kind of a non-issue here, but anytime you make a stem leaf plot, the smallest and the biggest number, and you list everything in between. Even if you don't use it, you would still list it as a stem. Okay? Then we just go one by one. So how can we show the number 34?
4.
We'd have to put a 4. How can we show 35? With a 5. 38? With an 8. You don't need commas. You shouldn't put commas. You won't see commas. Because it's always just going to be single digits. Right? How about for the 4s? We'd have 1, 2, 4. 7, 9, 9, and 0. Okay? You do have to write down each one. Even though it shows up more than once, you can't just ignore any repeats. Okay? Every number that's up here has to be represented on your chart. You should be able to count up the number of leaves at the end, and it should match the number of points in your set. So, very last one, how can we show 50? 0.
So if it was like 100, wouldn't it be like 360 would be 36 and then 0?
Yes.
Is that all we do for that problem?
So that's it. The only other thing you could make is a key. So we could say that 3 with a bar and the 4 next to it means what? 34. Okay? Just to help people who didn't have quality education be able to read your graph. So all of this is the answer. Please don't put a box around it. I'm just letting you know. If it says create a stem and leaf chart, then that's the answer, is the whole chart. Not right now. Okay.
Number 9's kind of hard. Wait, so how do we write that on the paper, on this board? Do we
Just put on my worksheet. All right, number 9. If y equals 3, what quadrant would y minus 1 y lie in? So this, it seems a little bit confusing, but really it's not that bad. If y is 3, what would y minus 1 be? This would just be 3 minus 1, and then what would this be? Which is 3. Then you do some basic math. What's 3 minus 1? 2. So what quadrant is point 2, 3 in? 1. If here's our grid, 2, 3 would be right about here. And it's positive, positive, which is quadrant 1. And in case you forgot, this is negative, positive, negative, negative is quadrant 3. So our answer would be in quadrant 1. All right, number 10. Rectangle has an area of 72 square feet. So we can make ourselves a rectangle. 72 square feet. If we have a scale factor of 6, scale factor equals 6, how can we find the new area? So the new area is equal to the original area times scale factor squared. Why is it squared? Because it's area, and area is in 2 dimensions. So our scale factor is 6 squared. Our original is 72. 6 squared is indeed 36. So let me just need to know what is 72 times 36. We get our answer. If you're saying, why is that answer so big? You think, well, if we increase by a scale factor of 6, that's getting a whole lot bigger. So you're saying every one of our side lengths is getting 6 times as big. Is that right? So 432 and 2160, does that look right? So we get 2592. So 2,592, what unit is that? Square feet. And that's it.
So basically, we get all these right if we remember that formula?
Yes, that's what I keep telling you. Every scale factor question comes down to this formula. If you can use this formula correctly, there's no reason to get any of these wrong.
So perimeters in 1 dimension?
Yes, but if you forget this formula, you're probably going to get everything that's not perimeter wrong. Okay? Because if you don't use formula, you're probably just going to say, what's 72 times 6? And the answer to 72 times 6 will be one of the answer choices. That's not like a maybe. It's not a 60% of the time. I mean, 100% of the time, 72 times 6 will be one of the answer choices. A lot of people will pick it, and a lot of people will get it wrong, and I'll feel like I wasted a lot of time. All right. Let's try to get a couple of these trickier questions on the back done before you leave. So that way you have less homework for tonight.
What are we doing?
The ones we don't do together. So the more we get done, the better. So we got Patty, some other girl, what's her face, and her, and 2 drones. All agreed to work on math. Patty finished a third, Deanna finished 1/5. Everybody else split up the rest. What fraction does Kathy still need to do? Okay. So we can start off, if Patty finished 1/3, other girl finished 1/5, how do we figure out how much they did combined? So you add it together. So we have a common denominator of 15. 1/3 is how many 15ths? 5. 1/5 is 3/15. So that is a total of. So those 2 ladies accomplished 8/15ths of the work. That is more than half. Okay? So how much work does that leave for everyone else?
8/15.
How many 15ths are left to go? 7. So there's 7 15ths left for everyone else to do. How many people do we have to work on that? 4, because we already used up this girl and Patty. So that leaves these 2 and these unnamed drones. 4 people. So how do you split up work between 4 people? What operation is that?
Divide.
We divide by 4. Okay? So then you just need to remember, how can we divide with fractions?
4/1.
We multiply, but before we multiply, we have to
Turn that into a fraction.
we have to flip it. So instead of saying dividing by 4/1, if we flip that over, we get 1/4, and then we can multiply. And then multiplying, we can just go straight across, and nobody has trouble with that. 7 times 1 is 15 times 4, 60. So each of the 4 ladies has to do 7/60ths of the work.
Wow. I would just do the rest then. It takes that much.
Not really. That's like 11%. Okay. Number 2, that's not that bad. Number 3 is not that bad. Actually, we can give you the formulas though. Volume of a prism, area of the base times the height. Pyramid, it's the same thing except we add 1/3 of that. Okay. Yes. Find the area of 2 bases of a cylinder whose height is 36 and bases have a radius of 1 foot. If all it says is the area of the bases, does it even really matter that's a cylinder? The only thing we need to know about the cylinder is that the base would be a circle. So really you're just finding area of how many circles? 2. And they're both the same size, and the area of that would be pi r squared.
So we're not doing that one together?
No. I'll give you the formula though, so you don't have to Google it later.
What number is it?
Pi r squared. Top half r squared.
Lightning strikes. This one you just need to know that it's not going to be 3.15. Please don't do that. Remember, it'd be 15 out of 60. Scatterplots are simple enough. Probability. None of these are really that hard. We can do this when we haven't done reflections in a while. So, 3, 6, 6, 2, and 3, 2. Where would all of those points be located?
Quadrant 1.
These would all be in quadrant 1. It doesn't really matter where you put them. There's A, 6, 2 is B, and 3, 2. Let's see. Okay?
Well, that means the right chime. Oh, no.
What do you see be under it?
Because it just is. If you look at the coordinates. I guess it would be more lined up, but whatever. Doesn't really matter. All we need to know, we reflect that over the y-axis. Which of these is the y-axis? The one that goes up and down. So if we flip everything to the other side of that, where are all the points going to end up? They're all going to end up in quadrant 2. Right? So what would happen to A? Which coordinate changes? The x or the y? X. Because it moves to the left. So instead of being positive 3, it would become... So A prime would be at negative 3. What happens to the y value?
It stays the same.
It stays the same. So it's still 6. And we're going to do that same thing with B and C. What's the only coordinate that's going to change? Just x. So B would end up over here. So B prime would be what? Would be negative 6, positive 2. And C? Would be negative 3, positive 2. And that's it.